What would you do if 20 seconds was all you had? 20 seconds to prove your worth. You have no memory of how you landed here, no mercy offered. With 11 others, you have to make it to the top 3. You make the 20 seconds count and by a miracle end up in the top 3. Then it appears a presence, a god, or something pretending to be one. It steals your DNA and creates little, slightly mutated copies of you. You wake again, similar arena, 11 others. But this time one of them moves like you, not exactly you but close enough to recognize. More decisive, a version that makes fewer mistakes. Evolution does not forgive, it does not pause, it does not care that you're still trying. You were never trying to survive the arena, you were trying to outrun yourself, and you were always going to lose. You know, as I'm explaining what I'm forcing my little creatures to go through, I do feel a sense of regret or bad conscience. But now is not the time to feel bad for a few bits and bytes. This is in the name of science. If you are unfamiliar with my work, I have created an ever-expanding ecosystem. In this world live the flat earthers, which is what I have decided to call them for now. The flat earther is the common ancestor of all the different species that exist today. I have yet to identify specific species, but there are herbivores, omnivores, and predators, each with their own unique traits. For example, plant eaters mostly have teeth toward grinding plants, predators with teeth toward eating meat, and omnivores usually have something in between. I have not forced any behavior, I have created a world that supports life, like planet Earth. I have not created predators, I have created a world where predators can appear through evolution. I only set up the parameters, so to be clear, I have not coded a predator and I have not coded a herbivore. I have not coded any behavioral patterns at all. They all appear through evolution. Today I want to see how well the creatures can learn to fight. Here I am definitely forcing a specific behavioral pattern by deciding who lives and dies based on how much they've eaten within 20 seconds. And at the end of this video, I will put all the best 1000 fighting creatures into one huge arena. In every arena, there are elements of what the creatures are used to seeing on flat Earth. There is a tree and plants. So in theory, the creatures could evolve to just try to eat as many plants as possible. But since I have confined them in a small arena with 12 creatures in each, I highly doubt we will see creatures with that behavior. Without further ado, let's see if we get this expected behavior by running the experiment for about 100 days. If the new generations of creatures evolve toward eating meat, they should develop a redder color. Nice. As we can see, the creatures have evolved towards eating meat. This means my setup works as intended. Notice that the creatures have grown really large. In the early stages where the brain have yet to develop more complexity, it makes sense that larger creatures dominate as they have more health and deal more damage, which compensates for their lack of intelligence. Other obvious downsides are that they are very slow and expend energy quicker, so I will need a lot more intelligence to be satisfied with the results of this experiment. Before we let the simulation run for a few thousand generations, I want to briefly discuss some new features of the creatures. On a technical note, besides creating this whole arena experiment, I have made it possible for creatures to evolve even more complex brains. I have done that by allowing extra neurons to develop. Before, the creatures were basing their decisions on their complex neural network brain. Now their brain can also calculate values for a neuron I have called a memory neuron. This value goes back into the brain as an input when the creature is about to make a new decision. What this means is that these memory neuron values can be used as a kind of memory. It can also act as something completely else I cannot even imagine. It is up to evolution to decide that. Before, the creatures were always basing their decisions on what they were seeing and their own personal state, like how hungry they were. These memory neuron values could be used as a flight trigger, so when it sees a predator, it turns around and runs. And most importantly, it remembers that there is something dangerous behind it, even though it has turned around. More than 4,800 generations have now passed, meaning the simulation has run continuously for over 26 hours. The creatures have evolved to become smaller, faster, and significantly more intelligent. What stands out, however, is that a clear tendency to avoid obstacles has still not emerged. Why might that be? We know that the beginning of each day is the most dangerous phase. Creatures rush toward the center, quickly selecting targets to engage. After this initial chaos, the dominant strategy appears to shift toward getting out of harm's way as quickly as possible. One possible explanation is that staying close to obstacles actually improves survival. Obstacles may make it harder for other creatures to detect or track you. In contrast, creatures moving in open areas are highly visible. Once another creature locks onto them, escaping seems extremely difficult. Near obstacles, however, a pursuing creature must process more visual information, which may reduce its effectiveness. Ultimately, even the strongest fighter gets no advantage if it's eliminated within the 20 seconds. Now it's finally time to see what will happen when we put 1,000 of the best fighting creatures in one big arena. Alright, blink if you're ready. Three, 2, 1. Almost immediately, a large percentage of the creatures are wiped out. Look, they can still lay eggs. Life always finds a way, even though multiplying for the benefit of survival was completely removed as a factor. Alright, now let's put the creatures up against the early creatures, those that are big and stupid. I think it becomes clear quite fast that smaller, faster, and more intelligent beats large and clueless. However, large and clueless was at the time the best strategy because it meant you had the most health and you dealt the most damage. However, due to the creature's intelligence increasing over time, this could not remain the best strategy. I wonder what would happen if we released the creatures into my flat Earth environment. Maybe we'll try that next time. I hope you enjoyed this video and I look forward to seeing you again.